Hello dear students, welcome to Tejama YouTube channel. So this is the second video from KCET 2027 series from the chapter Electric Charge of Fields. In this video, I am going to discuss about a new topic, that is Coulomb's inverse square law of charges. Okay, so according to which, if I consider two charges here, this is charge Q1 and this is charge Q2. In the last class we have discussed, if we consider two charges, they may get attracted or repelled depending on their polarity. For example, if I take two positive charges, they repel each other because like charges repel each other. And if I consider two negative charges, they also repel each other, yes or no? Two like charges repel each other. But if I take a positive charge and a negative charge, they attract each other. So unlike charges attract each other. So they attract or repel, but what is the magnitude of force? So here if I consider these two charges are separated by some distance, then the force between these two, that is force acting on first charge particle due to second charge particle, or force acting on second charge particle due to first charge particle, its magnitude is given by Coulomb's law. So according to which, here we have the statement, that is the electrostatic force of attraction or repulsion between the two point charges is directly proportional to product of magnitude of the charges and inversely proportional to the square of distance between them. Okay, so here according to which we have written the formula, that is F is directly proportional to Q1 Q2 by R square, and if you remove the proportional sign we will get 1 by 4 pi epsilon Q1 Q2 by R square. So where epsilon is given by epsilon naught into K, and that is equal to epsilon naught into epsilon R. Sir, what is epsilon here? This is called permittivity of the given medium. Epsilon naught is absolute permittivity of free space, and K is called dielectric constant, which is similar to relative permittivity of given relative permittivity of the medium. So that is given here, and if you substitute that here, you will get 1 by 4 epsilon naught into K. In the next slide, I will show you what is the value of K for different media. So this is for the given medium. What if free space is considered? That K value will be taken as 1. For vacuum or free space, K value is taken as 1. So we will use this formula a lot in board level and for competitive examinations. So including dielectric constant is very important. Okay, now what is epsilon naught value? Epsilon naught value is given by 8.85 into 10 to the power minus 12. So farad per meter you can call, or coulomb square per newton per meter square is the unit of epsilon naught. Then we have the value of 1 by 4 of epsilon naught, that is 9 into 10 to the power 9. Okay, now let us move to the next slide. That we have dielectric constant or relative permittivity, or it is also called specific inductive capacity of the medium. So it is defined as F naught divided by Fm. Okay, K is equal to epsilon divided by epsilon naught, that is equal to F naught divided by Fm. F naught is the force between the two point charges in vacuum, divided by Fm is force between two point charges in a given medium. So here we have the value of dielectric constant, just a minute, value of dielectric constant for vacuum, for insulating materials, and for conductors. This is very important for competitive examination. Clear? I'll move to the next slide. Here we have the properties of Coulomb force. So first property, Coulomb force is central force. Why? Because it acts along the line joining the two charges. So if I consider the first case, that is, here we have two charges. Okay, let's consider these two are like charges, maybe plus or minus. What happens? They repel each other. In which direction? Along the line joining the two charges. This is the line joining the two charges. Along that only they repel. But if I consider two unlike charges, they attract along the same line. Yes or no? They attract along the same line. That's why it is called a central force. Next we have, it may be attractive or repulsive because like charges repel each other, unlike charges attract each other. Then it obeys inverse square law. Just now we have written the formula for force, that is 1 over 4 pi epsilon naught q1 q2 divided by r square. Sometimes we write 1 by 4 pi epsilon naught as k also, k q1 q2 by r square. Okay. Then we have it obeys Newton's third law. Why? Because if I consider two forces, let's consider here we have q1 q2, two charges, and the force acting on q1 is the f1 2, and force acting on q2 is f21. Their magnitudes are same but directions are opposite. So that is given by f12 is equal to f21. But look at the direction. Direction is opposite, so we write minus sign here. So there is equal and opposite action and reaction forces here. That's why we call Newton's law base Coulomb's law base Newton's third law. Then we have Coulomb force is a two-body interaction. That means if two bodies are considered here and the charge is considered, if in case if I bring one more charge near it, this is Q3, will the force between these two charges change? No. So the F12 or F21 will not change. If at all, if I have to consider the effect due to Q3, we have to take it separately. That's why Coulomb force is two-body interaction. Then we have Coulomb force depends on the medium between the charges. Yes, that is true, because as I have written the formula, that is 1 by 4 pi epsilon naught into k q1 q2 by r square. So this k is called dielectric constant. Here also I have written k. This is k is nothing but 1 by 4 pi epsilon naught. But this k is dielectric constant. So F is inversely proportional to k. So that's why sixth point, that is force depends on the medium but inversely. Okay, that is between the charges. Next, we have Coulomb force in vector form. Let us discuss about it. Okay, so here we have two charges. Let's consider they are separated. In this direction, we have the displacement vector r12, that is the distance from 1 to 2, or you can take position vector from displacement from 2 to 1 is r21. Okay, let's consider these two experience a force, that is repulsive force in this direction. That is force acting on first one due to second one is left side. Force acting on second one due to first one is towards right side. Okay, now F12 is given by 1 over 4 pi epsilon naught q1 q2 by r square into r cap. In which direction? See, F12 is in the direction of r21. R21. Clear? Next, F21 can take, that is 1 divided by 4 pi epsilon naught q1 q2 divided by r square. It is in the direction of r12. Look at this, F21 is in the direction of r12. That's why I will take this. This is a simple way to write the Coulomb force in vector form. We have one more standard way also, that is by taking it in the displacement vector position, in the three-dimensional concept. We'll discuss about that in the NEET level concept. So next we have some questions based on this. Let us solve. So how does the force between two point charges change if the distance doubled? So here what is happening? R dash becomes 2 times R. Here distance halved, that is R dash is R by 2. Here dielectric constant is increased. Dielectric constant between the two charges is increased. So then charges are immersed in water. So what will be the force between the 2 point charges? So if you consider, since the force is inversely proportional to r square, for the first case, F dash, F new force is directly proportional to 1 divided by r square is 2r square. 2r square. So that will be 1 divided by 4 times r square. So new force will be how many times? Reduced by 4 times. So this will be the new force. Okay, next. Let us take the second question, wherein we have r dash is r by 2. So F is inversely proportional to r square. F dash is inversely proportional to r by 2 whole square. So that is 4 divided by r square. F dash is 4 times F. Next, C, dielectric constant of the medium is increased. So since we know that force is inversely proportional to dielectric constant, if dielectric constant is increased, force decreases. That is, force between 2 point charges decreases. Okay, next. Fourth one, charges are immersed in water. So simple, if F dash is taken, so F divided by K, because it inversely, the force is inversely proportional to K, therefore we'll get F divided by K. So F divided by K value is 81. So force decreases by 81 times. So this is about this. Let us move on to the next question. The force between 2 point charges are two charges placed in air at a distance r is F. So there is a force between two, related as K, Q1, Q2 divided by r square. K value is 1 by 4 pi epsilon naught. Okay. What must be the distance between the two charges? What must be the new distance? Let us consider it as small d. What must be the distance between 2 point charges so that the force becomes 3 times F? So how does force depends on distance? Force depends on distance as inversely proportional to r square. So new force should be 3 times F in case A. In case B, new force should be F divided by 3 times. For that, what should be the new distance? Right? Let us solve this. Since we know that F dash is inversely proportional to d square, because F is inversely proportional to r square, remaining all get cancelled. 3 times F inversely proportional to r square. That is the old force. Now what is d value they are asking? So d square is equal to, what is that? R square by 3. D is equal to r divided by root 3. So this is your d value. Here F is inversely proportional to d square. Here F is inversely proportional to r square. 3 as it is. So d square is equal to 3r square. D is equal to root 3r. So here the distance should be root 3 times r. Here the distance should be r by root 3. Clear? Moving on to next one. A point charge A of 10 microcoulomb and another point charge B of 20 microcoulomb are kept 1 meter apart. Let's consider. Here we have a charge. Here we have a charge. 10 microcoulomb and 20 microcoulomb. Both are positive charges. The electrostatic force on A due to B is F1. Okay. And the electrostatic force on B due to A is F2. Then, which of the following is correct? So, since their magnitudes will be same, I can take F1 is equal to F2. But if I take the forces in vector form, I get F1 is equal to minus F2. So both option B and D are correct, but if I take them in vector form, let me write the forces in vector form, then option B will be the correct one. Okay, moving on to the next one. 2-point charges Q1 and Q2 are placed at a distance r apart in air, and the electrostatic force between them is F. Okay, so there is a force which is K Q1 Q2 by r square. Now, if the distance between them is reduced to 1/3, then new force is F dash is inversely proportional to r square. So that is equal to 1 divided by r is reduced to, this is r dash square. Okay, r is reduced to 1/3, 1 by 3 times square, r square. So 3 3 is a 9, 9 divided by r square. So new force will be equal to 9 times the old force. That is option C is correct. Next we have 2-point charges A and B having the charges plus Q and minus Q respectively are placed at a distance, certain distance apart, and the force acting them is F. Let's consider two charges Q and minus Q are separated by some distance. They experience a force that is given by K Q1 into Q2 divided by r square. Okay, if 25% of the charge A, that is positive charge, is transferred to charge B, that is negative charge, the electrostatic force between the charges will be. So if 25% is reduced from this, that is Q by 4, 25% means 1 by 4th of that Q value is given to Q by 4, that is to negative charge. It is taken, subtracted from first charge, added to second charge. Then the charges becomes 4 ones are 4 minus 1 is 3Q by 4. 4 ones are 4 minus 4Q plus Q is minus 3Q by 4. This will be the new force. That new force is directly proportional to 3Q by 4 into 3Q by 4. That is equal to 3 is a 9 divided by 4. 4 is 16 times the old force. So 9 by 16, that is option C is correct. Clear? So next we have two positive point charges 10 microcoulomb and 20 microcoulomb are 1 meter apart in free space. So here we have 10 microcoulomb positive and plus 20 microcoulomb positive. They are separated by r is equal to 1 meter apart in free space. A third charge small q is placed on the line joining them at a point where the net force is 0. The position of q from the 10 microcoulomb is. So here there is a point along the line joining these two charges where the net force on this will be 0. Because force due to this positive charge on this one will be in this direction. Force due to this positive charge 20 microcoulomb will be in the opposite direction, F2. If F1 minus F2 considered, that will be 0 because F1 is equal to F2. That is where we have to place. So they are asking us to find this distance. What is this distance at which the net force is 0? For that, I will take it as x. Total distance is r they have given. So F1 is equal to F2. F1 is how much? K 10 microcoulomb into Q divided by the distance is how much? X square. That is equal to F2 is how much? K 20 microcoulomb into Q divided by R minus X. R value is 1. 1 minus X whole square. So microcoulomb get cancelled. Q get cancelled. K get cancelled. You will be having 0 get cancelled. 1 divided by X square, which is equal to 2 divided by 1 minus X whole square. Take square root on both sides, you will get 1 by x is equal to root 2. What is root 2 value? 1.414 divided by 1 minus x. So cross multiply, 1 minus x is equal to 1.414 into x, that is x is equal to 1 divided by 2.1414. So that will be equal to somewhere around 0.414. We will get the answer. There is a direct shortcut formula for this. So if two positive charges are given, the shortcut formula that you can use here is x is equal to, from q1 if you are taking, let's consider this is q1 and this is q2. So if you are taking the x value from q1, then x value is given by square root of, from q1 you are taking, so it is q2 by q1. If you are taking from q2, q1 by q2 will come. Okay, so this is equal to how much? This is 0.414. No, we'll get 0.414 as your answer. Okay, this is about this question. This is shortcut method that you can remember. For negative charges, one positive, one negative is given, then you have to take minus sign here. Okay, next. Four identical point charges Q are placed at the corners of a square of side A. Let's consider a square. Okay, so at the four corners we have placed charges. It is a square, it doesn't look like a square. Let's consider all sides are equal. So this is a square and we have charges. How many charges? Four charges placed at all corners, Q, Q, Q and Q. There is a negative charge placed at the center. So what is the net force on the charge? It will be 0. Due to symmetry, the forces due to all these charges get cancelled. Okay. Next. The force between two charges in vacuum is F. Okay. If a dielectric slab of dielectric constant K is inserted between the charges, filling the entire space, the new force between them is. So I will give you one shortcut formula here. If in case a dielectric slab is introduced here, of thickness T, okay, since the total distance between these two is R, this is Q1, this is Q2, so this is having the dielectric constant K, then the force between the two charges is given by F is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by R minus T plus T root K whole square. So this will be the force between these two. But here what they are telling, filling the entire space means directly you can take R is equal to T. So R is equal to T is 0. So T K whole square is, you will get R whole square, so and root K whole square. So we'll get the formula F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, because in this case R value is equal to T value into K is the dielectric constant. Now if the dielectric slab of dielectric constant 4 is introduced, so the new force will be F divided by K, that is F divided by 4. Option B is correct. Do you remember this formula? This is very important for NEET and KCET examinations as well as JEE mains. Next we have a total charge Q is to be divided into two parts, Q1 and Q2, placed at a fixed distance. The electrostatic force between them will be maximum when the charges are. Option B is correct answer. If the charge is divided exactly into half. Yes. Okay, sorry. If it is divided exactly into half, this is Q1, this is Q2, that is Q1 is equal to Q by 2 and Q2 is equal to Q by 2, then the force between Q1 and Q2 will be maximum. Clear? Then the ratio of electrostatic force to gravitational force between the two electrostatic electrons separated by distance r is of the order of. See, actually, I will directly give you the answer, that is 10 to the power 42. We can calculate it by using electrostatic force. Here we have electrons, okay, separated by some distance r. Then the electrostatic force is given by K E into E divided by R square. E value you know how much? 1.6 into 10 to the power minus 19 coulomb. Substitute it. K value is given by 9 into 10 to the power 9 units in SI units. Okay, and we have gravitational force also. For electrostatic force, this is the formula. Gravitational force, we should consider mass of electrons m1 m2, that is F is equal to G, m1 is me, m2 is me, divided by r square is same. If you divide r square get cancelled. We need G value, that is 6.67 into 10 to the power 11 units. Okay, then we have me, mass of electron, that is 9.1 into 10 to the power minus 31 kg. Clear? So this is about this. Option D is correct. If you take this electrostatic force divided by gravitational force ratio, so your answer will be D. Next, two identical metallic spheres A and B have 2 microcoulomb and minus 6 microcoulomb are separated by distance r. They are brought into contact and then separated back to the original distance. The ratio of new force to the old force is. So new force is directly proportional to Q1 Q2, sorry, old force. New force is directly proportional to Q square. So what is Q1 Q2? Q1 is equal to 2 microcoulomb, Q2 is equal to minus 6 microcoulomb. After, when they are brought into contact, the new force charge becomes Q1 minus Q2 divided by 2. Sorry, Q1 plus Q2 divided by 2. Q1 is 2 microcoulomb, Q2 is minus 6 divided by 2. 2 minus 6 is minus 4 divided by 2. It is minus 2 microcoulomb. Okay, so therefore, the ratio of new force to the old force is equal to minus 2 whole square divided by how much? 2 into Q1 into Q2, right? That is 2 into minus 6. I will just take the magnitude. Let's take the magnitude. 2 square is 4 divided by 2 into 6. 2 1s are 2 2s are 2 3s are 6. So 1 by 3 is your answer. Correct, no? 1 by 3, but it is not given here. So have you made any mistake? Here, two identical metallic spheres A and B have the charges 2 and minus 6 microcoulomb are separated by such a distance. They are brought into contact and then replaced back to the original distance. So Q1 is 2, Q2 is minus 6, 2 minus 6 is minus 4 divided by 2 is minus 2, minus into minus 2, 2 to the 4, and earlier it is 2 into 6. They are asking for the ratio of new force to the old force. Yeah, I am getting 1 by 3. I think this is the correct option. Next, we have a charge small q is placed at origin. Let's consider this is the x-axis. Oh my god, how to go back? Yes, she's not taking. Okay, let's consider here. This is the origin, x is equal to 0. So there is a charge placed at x is equal to 0 is rotating in the circle of radius r. Oh, this is about the rotation. No problem. So let's consider then a charge q is placed at the origin. Another charge minus 2q is placed at a distance a on the axis. It has missed here. Okay, I need to go back to this. Just a minute. Okay. A charge q is placed at the origin. Another charge minus 2q is placed at the distance a on x-axis. Let's consider here. A charge q is placed at the origin, that is x is equal to 0. Another charge minus 2q is placed at a distance a on x-axis, and third charge q placed at a distance 2a on the x-axis only. The net force on the charge at the origin is, see, due to this negative charge on this positive charge, there will be force of attraction. Let me write it as F1. That will be more. F1 is equal to K Q1 Q2 divided by A square. And due to this one, on similar positive charge, there will be force of repulsion. That is F2 is equal to K Q1 Q2 divided by distance is 2A square. So then the net force is F1 minus F2. F1 will be greater because distance is less. F1 minus F2. F1 is K Q square into 2 divided by A square minus K Q square by 2 to the 4 A square. So if you take common, K Q square by A square, 2 minus 1 by 4, that is equal to 4 to the 8 minus 1 is 7. That option itself is not given. 4 to the 8 minus 1, 7. K Q square by 4A square. Somewhere something is missing. Okay, so consider this is your answer. Okay, so here I can just erase this. Just a minute. Okay. A point charge small q is rotating in the circle of radius r around the fixed charge capital Q. The work done by Coulomb force in one complete rotation is. So work done in complete rotation. Okay, if the charged particle undergoes one complete rotation, it is not taking this rotation only. Yes, capital Q, there is a small q here. Since electrostatic force is a, what is that, a conservative force, work done for the complete revolution will be taken as 0. Okay, next, two identical metal spheres charged with 12 microcoulomb and minus 8 microcoulomb are kept at certain distance in air. They are brought into contact. So we have solved this kind of question. We can just take it as a homework question. Try solving it yourself. Yes, similar one to, I think it is similar to the question. Where is this? Brought into contact. Somewhere it has went. Okay, let it be. Q1, Q2 where we have written. Yeah, similar to this question. Okay. So consider it as homework. Next, 2 point charges 2 coulomb and 6 coulomb repel each other with a force 12 Newton. If each charge is given additional charge of minus 2q, the new force between them is. So F is directly proportional to Q1 into Q2. So F is 12 directly proportional to 2 into 6. So new force F dash is directly proportional to negative charges added, means the force charges will be, so 2q minus 2q is 0 into 6 minus 2 is 4. So F dash is equal to 4, 0. So option C is correct. Next we have, let B be the midpoint of the line joining AC or the segment AC. 2 point charges capital Q are placed at A and C. So Q placed at A and C, and B be the midpoint. Okay. What should be the value of third charge, small q, placed at B so that the entire system will be in equilibrium? For system to achieve equilibrium, if these two are positive, if I consider these two positive, this small q should be negative, because positive repel, and these two should get attracted so that net force will be 0. So what should be the small q? Let's calculate. Let's consider force, repulsive force is F1, that is the force between QQ, and attractive force is small q and capital Q. So FQQ is equal to F capital Q. The formula is K Q1 Q2 by, what is the distance between these two? Let's consider it as X, that is the midpoint, that is half of R. So I can consider it as R by 2 whole square, that is equal to K Q1 Q2 divided by R square. Correct, no? Yeah. K get cancelled, Q get cancelled, R square get cancelled, 2 to the 4, 4 will go up. 4Q is equal to Q. That is Q is equal to Q by 4, but this ratio should be negative. Here we have Q by 4, that is option C is correct, because small q is negative. Don't forget that. Clear? Next we have the unit of permittivity of free space. So you can just remember the formula, 1 divided by 4 pi epsilon naught q1 q2 by r square. They are asking the unit for epsilon naught, so you can just write 1 divided by 4 pi q1 q2 by f into r square. Yes or no? So for charges it is Coulomb square, for force it is Newton per Newton, for distance r square it is meter square, so per meter square. So Coulomb square per Newton meter square is your answer. It is there in option B. Clear? Yes. Moving on to next one. Two charges, 1 coulomb and minus 4 coulomb, exist in air. What is the direction of force acting on one charge? So 1 is here, minus 4 is here. So since they are, what is that? Unlike charges, they attract each other. So what is the direction of force acting on 1 coulomb? That is towards minus 4, towards minus 4 charge. Next we have Coulomb force is not valid for the distance. So Coulomb force doesn't exist inside the nucleus, so that is less than minus 15 meter, 10 to the power minus 15 meter. So this I have already given. The force, 2 point charges are separated by distance d in air and exert a force F on each other. If the dielectric slab is introduced between them, the force becomes, so both A and B are correct mathematically. Here instead of R they have taken D, so force is given by D square is given, no? Okay, no problem. The ratio of new force to the old force they have given, so both A and B mathematically are correct, so that's why I will go with the option D. Yeah, so here it is given, two charges are at the distance R, metal plate of thickness R by 2 is placed between them. So here if you consider, there are two charges. It is not taking straight line, so I will write like this. This is the slab. Two charges are given here. Let's consider Q1, Q2. Two charges are at a distance R. So this distance, complete distance is how much? R. A metal plate of thickness T, that is equal to half of total radius. You can take a bigger one also. Okay, this is having dielectric constant K. The force between the charges becomes, so F is given by 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. But F dash is given by 1 over 4 pi epsilon naught Q1 Q2 divided by R minus T, R D minus T plus T root K whole square. Okay, na? So what is the dielectric constant value? The metal plate. Oh, metal plate is given. Okay, for metal plate K value is how much? K is equal to infinity. So 1 divided by infinity is 0. So your answer will be C. Here identical, this is about symmetry. Identical charges plus Q are placed at n minus 1 vertices of a regular polygon. Here for our convenience let me consider a pentagon instead of n number of polygons, or you can consider a hexagon also. So n minus 1 vertices, so place a charge is placed. So total n vertices are there, but one is kept empty. At 5 places or vertices, charges are placed. Q, 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 Q. Okay. The direction of, the distance of the center from the vertex is R. Let's consider from here to here, distance is R. The net force on the charge capital Q placed at the center is, see, we have stated that net force at the center, or the point charge placed at the center of the polygon, when similar charges placed at all vertices of the what is this pentagon is Q, 0. Here the force will be 0, but here one of the vertices is missing, so therefore the net force becomes just K Q Q by R square, because one is missing. So net force should be equal to K Q Q by R square. Okay, so that is given in option B. And what is the direction? So that will be towards the empty space. Okay, if I place a small charge here, Q, it will exert equal force in opposite direction. Okay, then the force will get cancelled. That's why option B is correct. If you want, we'll discuss more about this in the next sessions. You can just comment me. Okay, this is about this video. Thank you so much for watching this video. If you find it is useful, subscribe and share it to your friends. Thank you.